This is Greg Pierce, the co-director of the UCLA Luskin Center for Innovation. I'm happy to welcome you to one of the final sessions of today's Climate Adaptation Research Symposium, where we'll focus our discussion on quantifying and minimizing water quality impacts. I am particularly excited about this session because I think it takes a sort of unique focus on the impacts of climate change on water. I think the relationship between climate change and water quantity is quite well understood and fairly intuitive, both in terms of the current events around and increased likelihood of both there being too much water and too little water, or there being flood or drought, and need for adaptation in that space. But I think the relationship between climate adaptation and water quality is less well understood. And I'm delighted that we have 3 speakers here today to speak to various ways in which climate change is and will impact water quality. In addition, I'm excited about these 3 panelists and their work in particular, because each of their different studies and sort of research agendas is both rigorous, but also very applied and focused on real world problems. And it's also focused on equity and minimizing sort of disparities in water quality impacts from climate change. With that, I want to briefly thank our event collaborators, particularly our sponsor, Edison International, as well as our various partners, both on the UCLA campus, around the state, and around the country. And then briefly, if you haven't joined us in previous sessions, mention that the widgets on the screen that you're seeing are resizable and movable. You can drag the presenter's video around your screen, and particularly want to also mention that we'll hear from each of the speakers in turn. Then there will be a question and answer time for each of the individual speakers. Then we will have a question and answer time at the end, featuring all the speakers. But we want to feature your questions, which you can put in the question and answer tab, clicking on the question mark that you see on your screen. So please submit your questions so we can feature those and the speakers can answer them. With that, I think that's all of the sort of introduction I will give. And I want to turn it over to each of our speakers in turn. Again, we have 3 different speakers representing 3 different universities, and we will start with the work of Dr. Allison Lassiter. And Dr. Allison Lassiter is an assistant professor in the Department of City and Regional Planning at the University of Pennsylvania. Her work examines opportunities to use landscape infrastructure and emerging technologies to build resilience and increase adaptive capacity in cities. And her work, as you'll hear about here, focuses on urban water management. With that, I turn the floor over to Allison.
All right, can you hear me now? Great. Okay, here we go. So this is a project that I've been working on at Penn with a colleague, Scott Moore, who's a political scientist, and our research assistant, Zoe Cavello, and I'm in city and regional planning. So today I'm going to talk to you about our motivation and research questions behind this study. And this study is in progress, so any of your feedback will help us orient it as we go along. Then we're going to talk specifically about the case of the Santa Ana Watershed Project Authority. Then the issue of chloride in drinking water, which I know sounds a little dry. It's the salt that, or subject matter dry. It's the salt that's introduced from ocean water. And then we'll talk about conclusions and next steps. All right, so this project really responds to two major problems. The first one is known as freshwater salinization syndrome. So this is the idea that a lot of inland water resources are becoming saltier. There's a lot of reasons they're becoming saltier. Some of them have to do with anthropogenic contributions of salt, like fertilizers, road de-icers, and even our wastewater. We are salty creatures. We eat a lot of salt, and our wastewater streams have salt in them too. But then there's also geologic contributors to salt. So this is a major problem along the Colorado River, where adjacent parent rock material just contributes salt to the river and is making the salinity in the river quite high. This inland water salinity is often measured by something known as total dissolved solids, or TDS. We're going to talk a lot about that today. Then there is also another contributor to salt, and this is much less discussed than the freshwater salinization syndrome. So one challenge is that sea level rise, well, let me say it a little differently. On the coasts around the world, there's 230 million people living less than 1 meter above current mean high tide. There's 1 billion people living less than 10 meters. And most of those people draw drinking water from just inland of the ocean. So there's a freshwater source right near the ocean that might be surface water or groundwater, but both of them are near the ocean. So freshwater, I'm going to do a lot of gesticulating here, hopefully you can see me, comes off the land to meet the ocean. And then this seam between the freshwater and saltwater is always moving. It moves when there's a lot of rain, the freshwater will push the ocean water out. When there's high tide or full moon, ocean water will push the freshwater inland. If we over-extract freshwater or we're drinking too much of it and not enough water is coming downstream, that ocean water will move inland. Also, if there's sea level rise, putting more pressure on the freshwater source, that salt water will move inland. This happens both above and below ground, this shifting boundary. We can call this the salt line. And so around the world, this boundary, the salt line, is just moving inland in many places. There's a few places it's not. It depends on local geology and environmental conditions. But a lot of places it is moving inland. So there's a lot of people that pull fresh water sources from just upstream of that salt line that are going to experience higher salinity drinking water. So this water that's coming downstream, that fresh water, is getting saltier because of the freshwater salinization syndrome. And then that seam, that salt line, is moving inland because of sea level rise. So the combination means that a lot of coastal areas will be experiencing a lot higher quantities of salts than they used to experience. That combined salt measurement of ocean salts and freshwater salts, that can be measured through TDS. But specifically when we're talking about ocean salts, we can think of that as chloride measurements. Okay, so what will we do about this problem of widespread salinization in coastal cities around the world? There are billions of people who stand to be impacted by this. It's going to be, my guess is this will be a major problem over the coming 30 years or so. So when I tell people about this issue, the first thing they always say is, well, why don't we just build desalination facilities? And this is definitely a solution for some places in the world. Some places in the world rely on desalination exclusively. It's a very expensive technology though, and it doesn't produce large volumes of water. The largest facility in the world is located in Southern California near San Diego, and it has a possibility of supplying about 10% of San Diego's water needs. It requires a large land area, it requires consistent energy sources, And it produces a lot of brine waste, which can be difficult to dispose of depending on the area. So desalinization is with complications. And for some places, it might be the best option, but for a lot of places, it is not the best option. And for a lot of places that don't have high financial resources, particularly when we think of this global context, desalination will not prove to be a very viable strategy. So what are viable strategies? What are the alternatives? Well, one possibility might be through watershed-based regional management. And the reason this could work is because, we talked about this freshwater, ocean water seam, is if we can manage freshwater flows at the watershed level, it's possible that it might be possible to repel that salt line, to push that salt line out. Particularly if we can manage the quality of water in those freshwater flows, it might be possible to introduce enough fresh water that the mixing zone remains relatively usable. So this idea of managing flows at the watershed level in order to repel the salt line, keep water drinkable for people in coastal areas is not well tested. There's a few places, though, that have a history of managing salt at the watershed level. To my knowledge, there's two in the US. One of them is the Santa Ana Watershed Project Authority, which is located in Southern California in Orange County, just south of Los Angeles. And the other one is the Delaware River Basin Commission, which is located in the mid-Atlantic of the US. If anyone knows of any others, I would love to hear about it. So in this project, what we're thinking about is, can we consider regionalization as a strategy to manage salinity? Will this help with this problem of the moving salt line and salinization of coastal water resources? So zooming in on SAPA in particular, and so we've started with SAPA, we're asking, what are SAPA's most successful salinity management strategies? And first, we try to isolate these by looking at TDS data, so this salt tracking data, and looking to see if we can graph salinity over time and identify different strategies that have led to decreases in TDS. And then secondly, we'd say, well, maybe we should just ask people what they think are the best strategies that SAPA has used. And so we conduct interviews with people who work for SAPA and for SAPA adjacent agencies. All right, so let's talk a little bit more about SAPA. So here's a map of SAPA. You can see on this little inset map, it's located in Southern California, mostly around Orange County. Right here, so Orange County's down here. So it's actually, it intersects 4 counties. It is 2,800 square miles. The river that runs through the center of it, that is really the focus of the watershed, is the Santa Ana River. It is 100 miles long. One major piece of infrastructure on the Santa Ana River is this thing called the Prado Dam. It's right here. It was constructed by the Army Corps in the 1940s for flow regulation on the river. There's about 6 million people that live in this watershed. So even though it's not a huge watershed, there is a huge density of people. Okay, so it spans these 4 counties. This is a little inaccurate. There's 4 member agencies and actually 1 utility that comprise SAPA. So SAPA is a joint powers authority, and these are its members. All right, so our first kind of hypothesis is that we'd be able to identify the best strategies for reducing TDS by mapping trends in TDS over time. TDS is measured at Prado Dam. So we zoom into Prado Dam and we graphed the concentrations of TDS from 1972 to present. So TDS is shown in this orange line here, and there's sort of spikes and valleys in it. You can see it is pretty much inversely proportional to the rainfall in the area. So the blue represents rainfall at the dam. what we've also done here is we've mapped on this graph the different policies, plans, and infrastructures that were built. So we sought to identify some trends here. This didn't prove to be quite as useful as we had hoped initially. So what we can kind of coarsely see here through the noise in the data is that salinity levels or TDS levels were quite high in the beginning of this project. And then they start to decline. This declining in TDS concentrations coincides with the construction of a piece of equipment known as the Brine Line, which I will return to briefly, or in a few minutes. Then after the construction of the brine lines, we have some declining levels of TDS. It starts to kind of level out and maybe even rise. So what's happening here? What we came to learn from talking with people is that the construction of the brine line allowed a lot of businesses in the area to dispose of their waste more efficiently, and so removed some of the brine from the Santa Ana River. But after that, things normalized. So wastewater treatment facilities that are located along the river are putting their waste in the river. And really it is this effluent that comprises almost all of the base flow in the river. So at times when there's no rain, the river is almost all effluent from wastewater facilities. The concentrations of salt in this effluent are going to remain relatively stable. So they've sort of gotten as good as they can get. And then meanwhile, a lot of the salinity in the area comes from historic agricultural practices, and there's still latent amounts of fertilizers and other sources of salt in the soils that are leaching into the river. So there is an increase almost in some TDS that may be a result of some of these latent salts in the soils in the area. So from this graph, it doesn't really seem, I mean, it looks like the brine line had some positive contribution to TDS in the river, but it's not clear that all of these plans and policies that went in place later contributed a lot. So the next thing we wanted to know is, well, perhaps this just isn't a good way of looking at or understanding what's happening in the area. And maybe a better way to do this is to examine interviewees' perception of success. So this is through our interviews. We asked people, well, what was the most successful project that SAPA took on? And what's the most successful partnerships that they have? So resoundingly across all interviewees, everyone said the most successful project is the Brine Line. So what is the Brine Line? For people in Southern California, you're probably really well acquainted with the idea of a brine line as a piece of infrastructure. This is not a widely popular piece of infrastructure, though. I don't know of any on the East Coast. There may be some in Florida, but not to my knowledge. So what this is literally a pipeline that extends from inland out towards the ocean. And SAPA owns and operates the Brine Line. And local wastewater treatment facilities, different businesses, they can all hook up to the brine line and put their most salty waste in the brine line. So they pay SAPA for access to the brine line here in order to meet regulatory requirements. The brine line disposes of 500,000 pounds of salt per day. And it is all treated down here by Orange County Sanitation District and then put out into the ocean. So what are the most successful partnerships in the area? Now this is a place where interviewees had some different responses. Many said SAPA itself was the most successful partnership. So SAPA formed this Joint Powers Authority because of so much litigation in the area. All of the different member agencies, starting in the 40s, began suing each other over different quantities and qualities of water that were released into the Santa Ana River. And the formation of SAPA has effectively stopped these lawsuits. Occasionally still someone threatens lawsuits, but usually they work together very well. There's high degrees of trust among member agencies, and there's a long history of collaboration at this point. Another person said one of the most successful relationships in the area was that of with the regulator. So the local regulatory board is the reason that everybody has to comply with some of these rules. So total dissolved solids, everyone is aiming to have under 500 milligrams per liter of dissolved solids in their waste contributions. So it is the regulatory body that enforces this. Cooperating with the regulator helps them come up with novel strategies and work together when there's more difficult environmental conditions that lead to things like reduced freshwater flows in the area, like less rainfall in the area. And then perhaps the last one that was, I guess, more novel to me was that a couple interviewees noted that one of the biggest benefits of SAPA is that coming together as a watershed to work on this problem and getting a little bit ahead of the regulatory requirements the partnership itself brought strength to the group. So they were able to better advocate. Well, they created relationships with state and federal senators and were able to better lobby and advocate for funding and bring money into the watershed. So rather than working individually, this group approach to watershed management brought a whole lot more financial resources to the area. So this has all been to manage TDS, and this is really focused on inland management of TDS. But we started this project looking for ways to think about managing salt in coastal areas that would also include chloride, so this salt that's coming in from the ocean. Now, in SAPA, which is this whole area here, it's really only down here, Orange County, that's adjacent to the ocean. This is its relationship to the Brine Line, and is experiencing chlorides coming into the water. So this is the one place really in the watershed that has this relationship to the ocean and has this relationship to chlorides. So beginning in the early 1900s, Orange County was overdrawing a lot of their aquifer in here. Now this groundwater they used for drinking water. And so they experienced seawater intrusion from overdrawing their aquifer. So they, have done a number of things to improve the seawater intrusion into the aquifer. And one of them, chief among them probably, is the system they call the groundwater replenishment system, which creates highly treated low salinity wastewater to inject next to the ocean and drive away the ocean water. Historically, they attempted to do this with some other sources of water, Colorado River imports, but these inland water sources were too salty to do that with. So this treated wastewater has worked out really well. This system is expensive and Orange County is really well funded. So they've been able to lobby for a lot of different funding and financing streams in order to build such a system here. This is amazing for them. It maybe won't be accessible to all places experiencing salinization. So conclusions and next steps here. One of the things that is very apparent is that Orange County, they need this lower TDS water that's coming off the Santa Ana River, and SAPA helps ensure that the water that reaches them is from inland is as low in salinity as possible. But SAPA does not really drive any sort of chloride management in the area. And as environmental conditions worsen, it's not really clear what resources SAPA will have to offer Orange County in terms of helping them manage chlorides. That's not the intent of the partnership. It was not designed that way. So what will Orange County do? Will other people help them? So one thing that is possible is that, click here, is that regionalization, so this idea of all of these member agencies coming together, has been really useful thus far in managing inland salinization, in part because of this threat of legal action to all of the different actors that are in the watershed. But now with chlorides, there's nobody to sue for that. And so who's responsible for minimizing chloride's introduction in the watershed? Now it could be that SAPA just ends up being a great source of continued lobbying for Orange County and helping them bring funding to help to manage this chloride problem. But there's really no one that's responsible in the watershed other than them for the issue of chloride. So this issue of coastal salinization, despite SAPA's massive success in coming together to manage TDS and all the innovation that's happened within the watershed, will push the boundaries of their historic collaboration. And it's possible that it won't be quite enough to help Orange County manage the chlorides in their watershed. We'll know better as we have better models on the impacts of seawater or sea level rise on seawater intrusion in Orange County's groundwater system as time goes on. But SAPA is not really designed to manage this problem. So our next steps in our project will be focusing on the Delaware River Basin Commission, which is more, their express intent is to manage chlorides from seawater, but they don't do it as much to manage upstream water quality. So they should provide an interesting contrast. Thank you so much for your time today, and I look forward to hearing your questions.
Thanks, Allison. And yeah, we now have time for, looks like 1 or 2 questions. I don't see any questions yet in the inbox, so please submit one now or at the end for group discussion. But I'll go ahead and ask one because you sort of alluded to it at the end there around Orange County and this sort of area within California and being able to secure quite a bit of funding and a perceived success of the program. Also being, relationship with different politicians or agencies, like whether there have been any critiques of the program, either within or without, around quite a bit of funding going toward a relatively wealthy region, as well as why you think perhaps other places up and down the coast in California haven't pursued something like this, given the broadly perceived success on a technical level.
Yeah, these are good questions, and we have more to learn here. So there was something called the Little Hoover Commission in California in I think it was the early 90s, that tried to promote more places in California following Santa Ana's model and adopting this watershed-based regional management. And there was a lot of pushback around the state. According to people that maybe are aligned with Santa Ana, they thought it was some resentment that Santa Ana had received so much funding and just wanting to stay away from Santa Ana. There are some places, well, specifically Central Valley, CV Salts was modeled after this. So it has been paralleled, but not as widely. It's not clear to me exactly why.
Okay. Yeah, that's interesting to hear that CV Salts was modeled on this, and I think we are at time, given the slight technical glitch we have, so I do want to transition to Ryan's presentation, but thank you again, Allison, and we can return to question and answer or discussion, I think, at the end.
Thanks,
so,
Greg.
Yeah, thank you. So next, we are going to hear from Ryan Sinclair. Ryan is an associate professor of environmental microbiology in the Loma Linda University School of Public Health. He has current research projects that evaluate human exposure to pathogens in surface water, on fomites in drinking water, in wastewater, and in tobacco water pipes. I will now turn the floor over to Ryan for his presentation.
Hi there, can you hear me? Okay, good. Let's see. So I wanted to start off by jumping into the name of this presentation. It's Arsenic Contaminated Groundwater Prompts a Community to Buy Water from Poorly Maintained Drinking Water Vending Machines. And so This presentation is going to talk about how people are kind of caught in a feedback loop in order to kind of drive their decisions on environmental justice issues. So this is the title slide, and the title slide also has an aerial photo of the Oasis Mobile Home Park. And this mobile home park it's about half as big as, or double as big as this picture here. So I'm working on this with my student Thomas Heil, who's a PhD candidate with us, and also Natalie from the Leadership Council for Justice and Accountability. And the Leadership Council, they're the ones that are in the community, and they're actually helping to organize some of the community members there. So our work here has been funded by the California Institute for Rural Studies and the California Endowment, and then it's kind of funded through several different nonprofit agencies on the ground there. Also, as a side note, I'm one of the 6 million that Allison was just talking about in her last presentation, but this community is just to the east of that, and they're not actually in the Santa Ana watershed. Okay, so what I'm gonna do today is talk about those couple of things there. There's that issue with the arsenic contamination, and then there's also the issue with the mobile home park. Hold on just a sec, I'm getting a bit of a technical glitch here. Alrighty, thank you. This presentation is going to focus on drinking water as one of the several environmental justice issues that the people in Oasis Mobile Home Park experience. The presentation I'm going to give is a mix of a case study, some published work, and some policy action by the Leadership Council. I'm going to start by discussing the case study and some of the acute environmental health problems that are happening in the Oasis Mobile Home Park. I'll then speak about bulk fill drinking water vending machines and those as an option for the arsenic issue that people experience in that mobile home park. I'd also like to make the disclaimer before I show all these pictures that I'm going to show you a lot of these challenging, deteriorated houses and living conditions. And then also the young families that live in those houses, they're all hardworking, organized, and motivated to make change to their current conditions. The pictures that I show you, it's where people live now, but just remember that this is temporary conditions. So these people are really organized and they really want to change things. But these pictures that I'm going to show you is kind of my disclaimer that, you know, it doesn't represent who the people are. It represents the current challenges that they're in. All right. So the Oasis Mobile Home Park is it has about 1,900 people in it, and it's grown to that size since about 2002, 2005. It's had about that many people in it. It's called a tribal Alati land, and it's located in the eastern Coachella Valley and is adjacent to several ag fields. This is an important point, the point about that it's on the tribal land. And that means that the county and state government have limited authority here. Also, the local tribal government is the default regulatory authority when this California state and then the county government can't do anything because it's on tribal land. And also there's the US federal government that's kind of above that. This mobile home park is about 5 miles north of the Salton Sea. Most households there are large family-centric, where 3 generations of family members live in the same mobile home. And a recent study found that their median household income is about $17,000 per year, combined median household income. And that's because most of them are seasonal gig workers or agricultural workers, farm workers. Most of them are Latinx, and several people belong to the Purepecha tribe. Let's see. But there's also a lot of other occupations there as well. And then just getting into that case study a little bit more, we had been going there for a while and looking at different issues there. But some of the most notorious issue with the mobile home park is the tap water. The tap water is treated well water, but it has several challenges. One of the challenges is that there's frequent water shutoffs there, often more than 12 hours at a time without warning. There's also the arsenic issue that I'll talk about a little bit more. The arsenic issue is that there's been a consistent amount of arsenic in the drinking water, well above the 10 ppb, or parts per billion MCL. Most samples range between 70 and 90 ppb, and that's samples that we've measured in our study there, as well as samples that the EPA, the US EPA Region 9 has taken. And that's from drinking water in the house. The major issue this is the major issue that's catalyzed most attention to the park, and that attention has come from popular media and also regulatory agencies. Another issue there is there's bacteria that's in some of the drinking water there. There's bacteria in a lot of the pipes that kind of traverse across the ground there in the mobile home park, because they're all kind of built ad hoc. So they're kind of built as they need them, and a lot of them aren't very deep below the soil. So you get a lot of breakage and a lot of cross connections with the septic systems in the community. Here's another aerial shot, and this kind of shows some more of the major issues there. There's frequent water leaks. This is a picture of a water main break, and every time I go there, there's always something like this that's happening. And I've been there several times in the last year. There's always something new, and this one was a water main that broke. There's also this over here. This is a really common occurrence as well. You have like a demolished house, the debris from that. Another thing that people are struggling with there is illegal dump sites. And so this whole area on the south part of the park is kind of where all the solid waste goes. The current management does eventually clean some of this up, but it takes them a while, and there's always some kind of new dump site that emerges. And again, this is the case study. I'm going through this first to kind of show you some of the challenges and then some of the policy solutions that come after that. The major habitability issues here are they're the water system leaks, they're the dump sites, they're the electrical infrastructure. I don't have a picture of that, but that's also a major challenge. And then also the trailer. And a lot of these trailers are pretty old, from the 60s and 70s. And they have several leaks in them. And those water leaks are throughout the community. A lot of these different mobile homes have them, and it's just a really common thing. And those leaks, of course, cause mold. And so we had a few years ago, 2018, we had the study on asthma risk being associated with mold contamination in some of these areas in the Eastern Coachella Valley. And we went and we found that there was higher levels of this moldiness index that we measured in trailers more than apartments and normal single family homes, and even some of the other types of homes out there. And we had a higher number of this index, and this is a mold index. It basically goes from 0 to about 20. And so anything above 5 is above 75% of what it should be. So you want to have less than 5. 5 is also the indicator that some of these EPI studies have found to be associated with asthma risk. And in that community, we actually surveyed several communities, but we had 2 mobile homes in there, and they also had pretty high levels of mold. But anecdotally, and then also with most of our studies, we do see that there's major issues with leaks. The unique thing about this is also related to climate, is you can look at these aerial images of the mobile home park, and you can kind of tell which roofs are going to be leaking and are going to be a little bit dilapidated through some of the better satellite imaging that you can do now. The other issue that I wanted to talk about was some of the other environmental justice issues is the one that's probably the most neglected and ignored. On-site wastewater systems in the park are also built in an ad hoc manner, just like the drinking water pipes. And several of the trailers that are there in that mobile home park, they actually share the same septic system or septic tank. oftentimes. And so that septic system consists of a tank and a percolation field, or it's supposed to at least. And most of the percolation fields weren't found during this recent US EPA audit. And there's also several of them are considered a straight pipe situation. So that's where the wastewater directly flows out of the house and goes into a ditch. Like this is one of those ditches, and it's been there a long time. So some of these situations have been long-term solutions that have grown trees and vegetation around them. Unfortunately, these shady areas attract dogs and children. My student Thomas and I are currently working on a microbial risk assessment to determine the health risks to children in these locations, because these kind of places where there's shade and water and trees, that attracts kids. And what if kids are exposed to that? And so we're actually doing on another study our risk assessment on that. So I wanted to just kind of present a timeline of events, because this mobile home park's been in the news a lot lately. So the history that I'm showing here over the last few years, it kind of sheds light on why arsenic is the linchpin to kind of start the movement in the park. The US EPA, it was the key here. I mean, there's so many other environmental health issues that, but arsenic was really the one that came out. So I first learned of the park in 2015 during our environmental survey over the wider area of the Eastern Coachella Valley. And we tested arsenic at that time, and we found in that trailer park, it was about 70 parts per billion coming out of the tap. Again, it's 10 parts per billion is the maximum contamination level. Since that time, the EPA has made several visits to the park and first declared an emergency order last summer, June 2020, regarding the drinking water and arsenic. That emergency order was lifted after they did some additional tests in July, and then it was reinstated again after more tests were done again in August. Our group was kind of responsible for that because we were actually monitoring for microbes, because I do more environmental microbiology work, and our group was actually monitoring for microbes in that park during last summer 2020, and then we also used our portable arsenic kit and then eventually submitted samples to a commercial lab. We found that there was arsenic in the water, so we expressed concern with the community about why that emergency order was lifted. And then when we were actually finding levels that were still above 70 parts per billion. So then their Region 9 responded to this news by conducting more tests, and instead of at the system level, which is where they tested it before, like right at where the water's treated, they tested it in the houses where we tested it, and they also found that there were high levels of arsenic. They reinstated the emergency order, and they also started conducting another assessment on wastewater. But the arsenic violation was what catalyzed the next events. I'm going to go over now kind of a series of local, state, and federal events that happened at the park. I could say that the local big event was the Leadership Council for Justice and Accountability that I work with Natalie. One of their attorneys submitted a lawsuit against the owners of the mobile home park, and that was kind of the local advocacy. And they had several different reasons to complaints in that lawsuit. It wasn't just arsenic. But as far as the state goes, there was also a request to have an additional $30 million available to help these people, and that was part of a budget in Senate Bill 129. And that was there to help the people get emergency housing support from the state government. There's also the federal level, and the community group actually reached out to Representative Raul Ruiz, who worked with the federal government to motivate the BIA to provide a resolution to the situation. And they were able to find some other documents. This is just recently, a few months ago, that they found that the Oasis Mobile Home Park operated without a lease for 15 years and had multiple deficiencies and risk factors in the wells and water distribution systems. But then eventually through the negotiations, the Bureau of Indian Affairs said they won't take any action to close the park. They're not going to be the ones to take that action. So it's kind of going back and forth again between this local, state, potential budget, and then the Bureau of Indian Affairs, and the buck is getting passed around back and forth because of the severity there. But ultimately that US EPA report was the one that kind of catalyzed it all to a solution, and or at least to get that Senate Bill 129 approved. And so that $30 million is now approved, that budget line item for the Oasis Mobile Home Park. And so that's going to start happening where people can be relocated with that money, or other options as well. It can be spent on to kind of help the housing issue there. But you know, all of these things happen, but there's still the major issue is that people still have to live in the park. So they still have to live in the park and endure the same situations with an uncertain landlord and management company. One of the main challenges as well is that the landlord recently passed away. So there's a lot of other legal difficulties with the ownership of the park. So we also did this study back in 2016, and we found some things about drinking water. We haven't published this study yet, but this is some of the data. Oasis is the census designated place where we had run our survey. And where these two red arrows are, this is just Oasis, only 38%, we found only 38% people actually drink their tap water from the faucet, and then and another in Oasis again, 30%, which was the highest out of all the areas, had said that they had their water turned off without warning. And then another really important statistic from this that we found back in 2016 was that we found that 100% of everybody, well, basically throughout the whole valley, except for in Coachella City, these people will fill their water jugs, so their 5-gallon water jugs at a vending machine, and they also all buy small bottles of drinking water. So that motivated our group to investigate drinking water vending machines, and those are available to them in the Eastern Coachella Valley around a lot of different areas. We found that most vending machines within 10 miles of those parks, especially the Oasis Mobile Home Park, they were not adequate sources of drinking water. We used a qPCR to monitor for a panel of pathogens, and so that just looks at the molecular signal for a couple of different pathogens. It was Salmonella, Listeria, Pseudomonas, Enterococcus, Campylobacter. Enterococcus and E. coli were kind of bacterial indicators, while the other ones were frank pathogens. And we used that, and we found presence of bacteria in 80% of the 25 vending machines that we studied around that area. And we did our samples actually by collecting 5-gallon jugs, something like 118 liters of water, and filtering that through some selective filters, and then actually running the PCR on those samples. And so it was pretty thorough assessment of that water, and we're confident we found the molecular signal for those pathogens in the water. And so what we're doing now with this is we're actually working with local groups to make some educational messages to communicate these results, because some of these vending machines are neglected. Users should learn a few tricks to evaluate them before purchasing water from them. We had this paper published on this in Water Supply just a little while ago, and that goes over some of the different findings that we had. But in conclusion on that, what we had to do was we have to make the communication on this, because people will still go to some of these spigots and they'll still get water from there. And especially people in this environmental justice, climate stressed situation, what's happening is that people end up going to these vending machines and then getting their water there without assessing the vending machine properly. And so one of the things is to actually look for evidence of inspections and maintenance, and you'll be able to use look for a county sticker or a digital readout The other thing is to look at the actual spigot, and a good way to do that is to get your, I'm just going to show you the like my smartphone. You get your smartphone and you put it on selfie mode and you put it underneath, and then you can look at the screen to get a good shot of the spigot. And that'll let you know if there's something like what you see here, rust around it or slime inside. Okay, so in conclusion on all of this, the reason I presented this case study first of like all the environmental health challenges, and then some of the policy things that happened, and then this water vending machine, just kind of show you like, well, all of this like grand policy and $30 million happened, but in the end, everybody in the mobile home park is still there and they're still drinking, and or hopefully not, but they're still being stressed, being in a water scarce situation. And they still have to go out and use these drinking water vending machines. So the arsenic contamination there, ultimately, it did a couple of things. It motivated the US EPA to consider the Oasis mobile home park situation and actually get some attention towards it. It also motivates the people who live there to do different things. It motivates people to purchase other sources of water. So actually, Greg Pierce had a publication just a few years ago on this as well, about how people, how much people have to actually spend on either bottled water or drinking water vending machine water. And then it also, the arsenic there also increases water stress. People are thinking a lot about water. And those are some of the things that arsenic kind of contributed to. Another issue with climate change and arsenic that I hear sometimes about that is people will assume, like other scientists and other agencies will assume that climate change is causing increases in the concentration of arsenic in the groundwater there. And that's why you're seeing so many more people exposed to it. That data actually doesn't exist yet, and we don't know that climate change has actually done anything with arsenic. But there is maybe some models show a marginal increase, but the most important thing is that water scarcity there is what's impacting people and kind of motivating all of these different actions that are a result of the arsenic. So that's what I have for now, and I guess I can take questions.
Great, thanks, Ryan. And yeah, presented a lot of work here and just tremendously important work. So I think there's a few questions. The first is around sort of what are the long-term solutions for residents in the Oasis Mobile Home Park? As well as I'd add a question of sort of how do we scale efforts to address other issues or similar issues in other mobile home parks that we're seeing throughout the state?
Well, really, the Oasis Mobile Home Park, they're really doing these interim solutions right now. They are, they're still going out to these vending machines and buying water there. They're also getting some support from some external agencies. I didn't show it, but in one of my slides, I had a little picture of the CVWD, the water district. They bring a truck over, so you have to go and fill up your water at that place. But you know, the Eastern Coachella Valley has had arsenic for a long time, and people are water stressed there for a long time. And there's very slow processes, but there is some new funds that have become available to tackle some of these things. Ultimately, they're really just thinking of extending current infrastructure out to where these communities are. So there's the Proposition 1 money that went out for that a few years ago. And so there's some work that's extending the wastewater and drinking water out to some trailer parks and some mobile home parks in the valley, but not Oasis, because Oasis is on tribal land.
Okay, thank you. And I think in the interest of time, we do want to move to the next presentation now, but again, hopefully we'll have more time for discussion at the end. So without further ado, I do want to introduce our last speaker, last but not least speaker here, who is Dr. Nate Jones. Nate is an assistant professor in the Department of Biological Sciences at the University of Alabama, and his research group has multiple foci, including examining fundamental eco-hydrological and biogeochemical processes, optimizing ecological engineering activities, and improving watershed management practices. But without further ado, I will turn the floor over to Nate.
Okay, can you guys hear me? Okay, perfect. Well, so first, I'm really excited to be here. This is a new audience, a new group of people for me. I spend most of my time working with biophysical scientists and presenting at places like AGU. So working with social scientists and public health researchers, this is, yeah, definitely a new place for me and a new venue for my research. I also start my presentation. I want to highlight my co-author here, Kelsey Piper. She's really the main instigator of this work. Kelsey and I went to grad school together an unfortunately long time ago. And we just, sorry, I'm going to start my timer on my phone so I know how far behind I am in this talk. And yeah, Kelsey's really the main driver of this work. And yeah, as I'll go through this, I'll talk about her contribution, and I do appreciate that. And the final thing before we get started, as I was making this slide deck, Hurricane Ida was making landfall in the Gulf Coast, so which is pretty close to home for me. I live in Tuscaloosa, Alabama, which is just north of the coast. And so Kelsey and I and others are working and doing kind of a follow-up study already on this work, which, as assistant professors is fortunate for us. But, when we really think about the people and the people that we're trying to help, these problems with well water and flooding of wells are going to continue, and they're going to continue into the future. So hopefully this work and others work will spur, improvement for these communities. So before we get too far, I do want to thank the funders. So an NSF Rapid Grant funded most of this work. Kelsey was also funded through a USDA NIFA fellowship. And then finally, FEMA also helped because this work was associated with Hurricane Harvey. We recently published this in Environmental Science and Technology, and we were able to make this open access. So anyone in the audience, you should be able to download this freely on the ES&T website. If you can't, shoot me an email or tweet at me, and I'll definitely send you a copy of this publication. And most of what we're talking about today is contained in that publication. Okay, so the big research thrust here, the big question is, what happens to private wells during floods? There's limited data on what is actually happening when wells flood. How do wells, what are the processes and the mechanisms that lead to well contamination? And how can we use those to, one, improve well design or engineering interventions, and two, identify wells that might be contaminated post disasters. And one example of this is a picture from a well user in Louisiana after one of the recent hurricanes. And the well user asked an extension agent, well, my well box was underwater, 7 feet underwater for over a week. Is my water safe to drink? I grew up on a well, so this is something that's near and dear to my heart. And it's a question my parents, and if I was on well water now, I'd be asking too. This is very tangible, and that answer, unfortunately, isn't necessarily easy unless you can have quick access to testing, and not everyone obviously has access to that. This is another example of a well user. Actually, Kelsey and her team were out, and this was another study, but they were looking at the premise plumbing, and they were working through the premise plumbing, and they went out to take a sample at the well box, and the homeowner flushed the toilet. And as they were taking the sample, they saw the blue toilet cleaner, the toilet bowl cleaner that you put in your toilet to clean it. They saw that in the wellhead sample. And so, I'm at heart, I'm a hydrologist, and I study hydrologic flow paths and use a lot of hydrologic tracers. And this is, it showed that there was a direct connection between that on-site sewer system and the drinking water. So obviously, the response to this homeowner, unfortunately, is like, no, don't drink your well water. And again, the point here is to highlight that these are real tangible problems that people are facing and questions that we need to answer quickly. And so today we're specifically going to focus on Hurricane Harvey. Hurricane Harvey made landfall. And really, Houston took a direct shot. Some areas received over 18 inches of rain. And importantly, the thing that I want to draw your attention to here is that this was a problem that occurred both in urban areas. And so I have this picture, this iconic picture of Houston up here, and then also in rural areas as well, because the areas outlying Houston. And so the questions we're going to ask are, what are the impacts of flooding on private wells? And then more pointedly, what are the potential drivers of well water contamination? And then we'll also look at potential engineering implementations or management solutions that homeowners currently can take to address these challenges. Unfortunately, we don't necessarily have any direct answers, but we do hopefully have some research directions that are going to help us get those answers. And so it's really important. One of the great things about this study is we just had a huge number of samples. In fact, as far as well water studies, I think this is one of the largest samples post-hurricane that's been published to date. So we had almost 9,000 samples. 1,500 of those samples were associated with the RAPID grant. The remaining samples came from Brazoria County and the City of Houston health departments. It's really important to note here that none of this would have been possible without the Texas Well Owner Network out of Texas A&M. The relationships that they had established and the well programming that they had, the well water programming they had before the event were crucial into the success of this sampling effort. This graphic, I don't want to dwell on this too much because it's a little complicated, but the point here is that we did have these three separate sampling efforts. So in the figures and plots that I show as we move through this presentation, don't necessarily all represent all 8,000 samples. We used different sets of samples for different parts of the analysis. I also want to highlight, and this is really was my contribution to the project. We used publicly available geospatial data sets. The first was the USGS well data set. So this is a national scale spatially distributed model of where well users are. This is a wonderful resource. Until very recently, I think it was the only resource that we had that estimated where well users are. And if many of you probably work in well water and know that it's really difficult to map where well users are. And so this is a wonderful resource. However, it definitely has its limitations. The biggest of which is it's based on the 1990 census. I was born around 1990, so a lot has definitely changed since then. And I'll talk about this at the end of the presentation. This is an area of that's ripe for room for improvement. We also used remotely sensed data from the Dartmouth Flood Observatory at the University of Colorado. We used some of their products to estimate the flood extents, and we're really grateful for that resource because we didn't have to do any of the image analysis ourselves, which is quite beneficial to our project. And this is I don't want to spend too much time on this, but I would love to talk more in the Q&A about our scale of inference. But this is kind of what that data looks like when we scale it to the county level. And this is the coastline here, and Houston is kind of in the center of that coastline. Okay, so diving back into the study objectives, what were the impacts of flooding on private wells? And so first and foremost, there were thousands of private wells that were likely impacted. There were roughly 41 counties that were declared disaster. And so those are the counties shown in these maps below. 6% of the population across these counties, and we estimate about 6% of the population rely on well water. But that's still half a million well users. So that's quite a bit of people, right? And then of that well user population, roughly 3% were inundated, or that's what we predicted using this spatial overlaying the predicted inundation and the predicted well users. And so that's roughly 15,000 well users. And you know, it is worth saying that yes, this is a small population of people, but it's still a lot of people. And we hope that our research kind of puts a spotlight on this issue, because we're seeing this now with Hurricane Ida. The well users are often overlooked because there's so many problems post-disaster. And so hopefully some of the research that we're doing and others are doing will help help put measures in place so these folks aren't left behind after the next hurricane, because as we've been talking about, these are going to continue to occur, especially. And one thing that I kind of alluded to earlier that's really important is that the flood impacts weren't just in rural areas. When we think about well users, most of us think about folks in rural areas. But what we found in Houston, and we're seeing this again in Hurricane Ida, especially where it when it made its way into the Northeast in New Jersey, that there are well users in areas that we would consider urban, or areas that are more urban. And so when we look at per capita, we see that yes, there are a greater reliance on wells in rural areas, but at least in Houston, there's a larger number of well users in urban areas, and that just has to do with, well, there's more people in urban areas. And so this plot kind of takes a closer look at that. So the y-axis here is the percent of well users inundated in affected counties. And then the x-axis is the percent of population that are well users in affected counties. And then so what you see is we've got PDFs on the opposing axes, and that's really where I want to draw your attention. And so, like I was saying, you see that this orange area, you do have a higher percentage of rural people relying on wells in rural counties. But when you look at the percentage of people affected, it ends up being really similar. And then when we look at the raw numbers again, we do see that at least in this area and for this storm, we did see a larger number of people well users impacted in what we're calling urban counties. And I think it's really important to highlight, we're not necessarily talking about urban city centers. We're talking about anything, we're using the CDC's classification index. And so really, a lot of these areas are somewhere, in the suburbs or in this gradient where we have development or urban sprawl moving out into the county areas. Okay, so we're going to look at potential drivers of well water contamination, and I want to be careful here because there's probably some economists in the room, so we're not actually drawing any causation here. We're just looking at correlation, and so that is important as we walk through this next step. So on these graphs, we're looking at contamination rates, and so in the yellow is total coliform, and then the orangish red is E. coli. And so on the plot on the left, that's the positivity rate on the y-axis. And then what you see is the dashed line are those are the baseline levels of contamination that the Texas Well Owner Network had recorded in the past. So what you see is, yes, we did observe elevated total coliform levels, but what's really important here is that we saw almost an order of magnitude increase in E. coli contamination rates. And then when the plot on the right, where we're looking at submerged versus not submerged, you do see increased rates with submerged wells, and that's going to be honestly that's a no-brainer, but also that's a common thread throughout this presentation. When we look at the odds ratio, we see that the best predictor of contamination is when the well owner self-reported that their wellhead was inundated. And again, that makes sense, right? If floodwaters, contaminated floodwaters overtop your well, if that well's not properly protected from those well waters, then you're going to have contamination. But what's also interesting here is that when we look at inundation based on the remotely sensed inundation area, we see that that's actually less of a predictor of that's less of a predictor of contamination. And this has to do with this issue of scale, and also points to, well, maybe we should be using higher resolution aerial imagery to predict this inundation, which is actually a very difficult thing to do. Finally, the other thing that I want to draw your attention to is people's behaviors, or at least their self-reported behaviors. Over here in the area highlighted in the yellow, also were predictors of contamination, or at least slight predictors. So if you're not using your water for cooking, or if you're not using it for bathing, well, that actually there might be something to that. Folks have a pretty good idea that their water was contaminated. And then finally, I want to kind of look at some of these practices of shock chlorinization and natural attenuation to look at well recovery. And I don't want to spend too much time on this. It's worth saying this is really Kelsey's area of expertise. She actually recently, I don't know if it's published yet or not, but she's recently put out a study looking at shock chlorinization and when it should be used and when it shouldn't. And the important thing I want you guys to take away from here is that really when shock chlorinization was used, so essentially this is the standard practice, the SOP that extension agents tell well users to do after the well's been flooded. When that occurs, it doesn't always reduce contamination. And there's a lot of reasons for that, and there's a lot to unpack from here. And I don't necessarily have the expertise or time to do that, but that's actually a bit scary, because oftentimes the extension agent will tell the well user, hey, if you dump chlorine in your well and you follow the shock chlorinization procedures, you're good to go. And that's obviously not the case, and that was one of the major findings with this project. We did see that there was recovery over time, and it's important to note that these weren't repeat samples. So there is limited inference here, but what you have on the y-axis is coliform incidence rate, and then the y-axis is time. And so the storm happened in September, and then we saw a decay of the TC and EC positivity rates over time. And so this begs the question, what's driving well water recovery? And I'll talk about this more in a second, but that's something that we're really interested in digging into more. Are there key variables that maybe we can tweak and use in a management situation that we can help well owners increase the speed of this recovery? Okay, so the things I want you to take away, private well, they're impacted in both rural and urban areas. Inundation was the strongest predictor of contamination. And so if your well's flooded, there's a good chance that it's contaminated. And then finally, disinfection. So shock chlorinization, which is the SOP, it was not always effective, and that was one of our bigger takeaways. And so the things that we're working on now, and the things that we're really kind of excited about, is one, how do we predict where private well systems are? This is a tool that emergency managers and public health departments could utilize. This is something that's tangible and needed, and we just don't have a good handle on where our well water systems are. And so this is an area of ripe for research. I have some ideas on this. It's something that I think Kelsey, co-author, she has a student that might start working on this soon. So yeah, I think this is a next step that needs to occur. Another thing that we're really interested in is understanding the connectivity between floodwaters and well water. So what mechanisms are driving floodwaters getting into the well water? Is this simply just old wells and aging infrastructure, or are there hydrologic processes that are driving those? And honestly, it's probably both. And then finally, we want to dig more into the physical, chemical, and biological drivers of well recovery. And the point here is, we of course we want to have these academic studies, but can we use this information to actually provide actionable resources to extension agents and well users, and empower them to improve their water quality? And with that, I really appreciate your time. Again, I was really excited to speak. And yeah, if you have any questions afterwards, please feel free to reach out to me or any of the co-authors.
Great. Thank you, Nate. And I don't yet see any questions in the Q&A, but I did have a question, and I'll start there around if you could explain a little bit more on two fronts. A, the natural attenuation and kind of what that means or how that works. It's not intuitive to me, although I'm a social scientist through and through, as well as if there's anything that can be done in situ. Maybe you mentioned it, in areas that are inundated, but it can reduce the extent or prevent it altogether.
Yeah. So the natural attenuation, and this is actually a conversation we were having with the Mississippi State Extension after Ida, is that it would be really great if we knew what was driving this well recovery, because if natural attenuation is just occurring because the groundwater is mixing with that well water, right? So through diffusion processes, and it's just naturally the contaminations leaving the well. Then if that was the case, then we could just tell the well owners, hey, pump your water, right? And you could pump that bad water out, and that would fix your problem. The reality is it's probably not that simple. There's probably biofilms and other things forming in the well itself that that's harboring those pathogens and other things. So maybe that's not the best approach. But if we could, or as we learn more, there may be cases where just a physical process can actually remediate the well quickly. And then your second question, and please interrupt me because I can go on for days. The second question is there a way to prevent the well from actually having floodwaters move into it? And yes, absolutely. Wells, especially more modern wells, they're built that the caps are sealed, and the tops of the wells are also, the grout is sealed in such a way. The bentonite cap is, so there's like a physical cap that goes over the well, like a metal piece of infrastructure, and then there's a bentonite cap that goes around the edge that kind of seals the physical, like the well itself, against the ground. And those two things, if done properly, should prevent well or floodwaters from being introduced into the well. However, over time, those things start to degrade. And also, it's not only the infrastructure, the built environment that we worry about. There's also, especially in these coastal areas, there is surface water, groundwater connectivity. So those floodwaters actually may be reaching the especially shallow wells directly through the sand aquifer. So yes, it could be an infrastructure problem, but it could also just be natural processes or hydrologic processes driving that.
Okay, and then one final question for you. Do you have any guesses as to why the chlorination didn't work? This is a question from the audience.
Again, this would be a wonderful question for Kelsey, and she's going to probably stomp on my toes the next time she sees me because I'm not going to answer it correctly. But my understanding is that the contamination in these wells the hypothesis is that the contamination was likely there was so much contamination that there just wasn't enough chlorine introduced to kill all the microbes. But that's secondhand from Kelsey, so I would definitely defer to her. And I believe she just published a paper on this, a big review of shot chlorinization. So you should definitely look that up.
Okay, great. Well, now I'd like to welcome back Allison and Ryan as well. And I encourage the audience to submit questions for all three panelists, or that could potentially apply to all three panelists or individuals that weren't asked before. And I know, Ryan, it looks like you replied to some of the questions in the chat, but I'm going to go ahead and ask a question to all three of you, which I hope you all could lend different perspectives on, which is, we've heard from the three of you really different entry points at which climate change is impacting water quality from the source to the point of use and everything in between. So the question I want to ask is whether you see the need for sort of different regulatory or funding or solution-oriented approaches that are more comprehensive and holistic and take on the challenge of climate change specifically with relation to water quality, or do you see existing tools and kind of a piecemeal approach being potentially more effective or just more realistic? And again, I welcome anyone and all of you replying.
This is such a great question, Greg, and it's one I think about all the time. For salinity, it's not something that's regulated very clearly. There's suggested guidelines, but there's not firm enforceable guidelines most of the time, in part because it's difficult to establish health causations with most types of salinization. So there's kind of two layers to what I've been thinking about. One of them is like, yes, our current regulations they're not really set up to address kind of the next round or like sort of a lot of emerging contaminants, which aren't even pharmaceuticals and PFAS and PFOA, but things like salt. But at the same time, we are also faced with this issue of the cost of serving clean water to people. So with new regulations going in place with PFAS and PFOA, like this is going to be a huge financial burden to so many water agencies. And I literally don't know how they're going to get around it. So as we put in new regulatory requirements to meet our clean water needs, we probably also need to think about new funding and financing mechanisms, or bolstering the ones we have, like clean water, drinking water, revolving funds. But it's a difficult issue, and I really am not sure how we'll proceed with it.
Ryan or Nate, do you have any thoughts?
Can you restate the question again?
Sure. Just whether existing regulatory or sort of funding for solution approaches can address what you all discussed, which is impacts of climate change on water quality from the source to the point of use and everything in between. Do the existing tools work well enough if patched together, or do we need something that's more holistic around the ways in which climate change can affect water quality?
Well, definitely agree with Allison on some of the parameters that we look at are kind of the wrong targets as far as she was talking about salinity. But for me, it's arsenic seems to be the thing that catalyzed everybody into action in the Eastern Coachella Valley. But there was a lot of other environmental health issues there. My favorite one, of course, is the wastewater, because I feel like that's a severe issue. And we don't really have a good way to say how people are exposed to wastewater, like what Nate was talking about with the blue dye from the toilet coming up into the water. We're having that issue in a lot of places, and I don't think that there's really good policy about that. And if there is, it's not very well enforced. California has this thing called the human right to water, and that is about drinking water. And that, just gets into drinking water, that everybody has the right to safe, clean drinking water. But it kind of doesn't have much teeth in it either. And it also doesn't talk anything about wastewater. So from that side of it, there's that answer about like current parameters that we look for. And then, what are we actually looking at to get to some of these public health problems to solve them? So I don't think those are adequate. So I'm a bit pessimistic on that, I guess. But then there's the other issue of the funding mechanisms. And one of the problems that we have working in trailer parks and mobile home parks is that the funding mechanism, the one that just came down the pipe is, it's kind of a pun, I guess, but that the one that just came down in California is going to start funding some water issues in California, but it'll go to water districts. And again, that makes it one more step away from disadvantaged communities. It's kind of just like this this COVID-19 and the renters relief, where it goes to landlords instead of going to people. So instead of going to the renters. So there's that side of it as well. Anyway.
Nate, do you have any thoughts?
So I spend most of my time, well, I'm going to answer this in two parts. The first is like kind of a broad academic answer, and then I hopefully provide more of a direct actionable answer. So my broad academic answer is, I spend most of my time working in natural systems. So, upstream of the drinking water plant or the private well system. And I often, in prelims, I ask my grad students in their preliminary exams, how would you rewrite the Clean Water Act now that we know so much more from 1973? And I'm not suggesting that we should scrap the Clean Water Act, but I think it is worth contemplating how we would update our these large legislative things that we or mechanisms that we rely on. And then for my actionable answer, so private well systems in most states aren't regulated, or there may be some regulations, but they're typically not regulated at all. And so our work, we're doing the best we can to get information to the well users to enable them to make the best decisions they can. And so that's I don't know if that's a real answer or not, but that's the approach we're taking right now. And that's a very localized approach, and it's not top down, but that is what we're trying to do.
Okay, yeah. Thank you so much for everyone's response. And unfortunately, we're already out of time, but I appreciate, and I want to thank especially our speakers, Allison, Ryan, and Nate, and encourage everyone to follow their work on this topic going forward. And I do also want to mention, because some folks have asked in the Q&A, that this session has been recorded and will be posted, so it will be publicly available. And then last but not least, I want to thank participants for coming and encourage you to come back tomorrow. We actually have 7 more sessions running through midday tomorrow, and encourage you all to engage more broadly, in the work of climate change adaptation, whether you're coming from academia, public sector, private sector, nonprofits, because we need all hands on deck. And again, thank you to our speakers for the work you're doing in the space. And thanks to everyone for joining. Have a great night.
Thanks, Greg, and thanks, everyone.
Thanks. Bye-bye.